Example 3, for queuing problem, we read first the problem. The photocopy center at the business management faculty has one photostat machine. The inter-arrival time of students at the machine are as follows. Photocopying is done on the first come first served basis. Analysis of past data has shown that the amount of time required for each student to make photocopies has the distribution shown below. Okay, the owner feels that under the present situation, the waiting lines in front of the photostat are too long, and the time a student spends in the queue and waiting for the service is excessive. He wants to better serve the student. Assume the center open at 9 a.m. Perform a simulation for 15 arrival using these random numbers for inter-arrival time and also photocopying time. Based on the simulation, answer the following question. Okay, so in this example, you need to solve for the random number interval first. Okay, since we are given the two table for probability value, if you see for probability value, you should make this interval first, random number. So again, how to construct your random number interval by using the cumulative probability value. Okay, look at the last two digits to locate at this point, the higher limit, the upper limit there. Start with 01 up to the first cumulative probability value for the last two digits. Okay, that is 20. Next, after 20 is 21 up to the second cumulative probability value lah. Okay, until we get 96 up to 00. And then for photocopying time also, you need to construct the random number interval. Next, okay, since this is example, you are given this table to fill in the values. Okay, I have write the answer for you, but in the real problem or question, this you doesn't have this table. You need to construct by yourself. So we start with arrival. So the first arrival need this. I explain the scenario here. So we start with first arrival. We use the first random number. TBA is time between arrival. Okay, time between arrival, that's mean when the center open at 9 a.m. after 3 minutes the first arrival have come to the center. Okay, so that is 9:03 because after 3 minutes then the first customer or first student enter the center. Okay, that is 9:03, and then the first student get the service time is 4 because I use the random number 2. Okay, that is photocopying time, or service time. So the first student start to photocopy at 9:03. Maksudnya he or she arrive at what time? No customer yet, so arrive, and he or she will definitely start the photocopying time. So start at 9:03. How long it takes? It takes about 4 minutes lah kat situ. So 4 minutes from 9:03 up to 9:07, and ending service time. Maksudnya the first student to finish photocopying at 9:07. So no waiting time involved lah, because he or she is the first customer to arrive. Next arrival or next customer or next student, we take the second inter-arrival time, that is 4. So the first arrival student is 9:03. Next arrival gap between the first and the second is 4, so you need to plus 4, that is 9 907. Okay, 907, the second arrival arrive. So start photocopying after he or she arrive at 907. Okay, so how long it takes? It takes about 4 minutes lah, because I use the second random number for photocopying time. So 907 to 911. Okay, no waiting time involved. Because why? Because after the first student finish, then the second student arrive. Okay, tepat-tepat je kan. Next, the third student arrive at 908. Because why? Because the TBA, time between arrival, is 1. So 907 plus 1 minute is 908. Okay, you can imagine the second student still processing the photocopying, but the third student have arrived. You need to imagine this scenario lah. Okay, so at 9:08 a.m. the third student arrive, and then he or she will start the time after the second student have finished, that is 9:11. So time between this, we call it as waiting time. He or she need to wait after he or she arrive lah, nampak? From 9:08 to 9:11, he or she need to wait. Yeah, that is waiting time lah kat situ. So how long he or she have to process the photocopying? 5 minutes. 5 minutes. So 9:11 to 9:16. But waiting time equal to 3, because 9:11 you minus with 9:08. Walaupun dia sampai, dia tak boleh start photocopying, dia kena queue dulu, dia tunggu habis student yang kedua ni. Okay, so dan seterusnya. I hope you understand how the process is. You need to go one by one up to 15 arrival. Okay, so after we simulate, we have to answer this question. By 9:30 a.m., how many students have arrived? So you count lah. By 9:30 a.m. here, okay, you look at your table. By 9:30, mana 9:30? Arrival 9:30. How many students have arrived? So we have basically 11 student lah sini. Arrival time 9:30. So kita sempat masukkan 11 student kat situ. So your answer equal to 11 arrival or 11 student. How many are served? Okay, kalau kita tengok kat sini, yang sedang menggunakan sampai 9.30. Okay, kita ada kat sini 9:28, dia start guna tapi habis 9:35, tak apalah. So kita ada lebih kurang sini 7 student have been served. Okay, 7 student. Okay, next, mana average time student spend queuing. Okay, at the end dia kata the owner will only provide another machine to better serve the student if the average time student spend queuing is more than 10 minutes. Okay, so you have to find the average first. You compare lah. So I get here 12.33 minutes. So yes, the answer yes, because average time student spend in queue more than 10 minutes.